Hi everyone, welcome back. In this video, we're going to answer the question, is water a polar or a nonpolar molecule? Will water be expected to stick to itself? The first thing we need to do is ask ourselves, what do we need for a molecule to be polar? You must have at least one polar bond, and you have to have a three-dimensional shape, a Vesper shape, that gives rise to a net dipole. And a net dipole is a partially negative end and a partially positive end. We always start with the Lewis structure. Sorry, I got to get my electronegativities. H20. I have one oxygen. He's going to bring me 6 valence electrons. I have 2 hydrogens. He brings me 1. That gives me 8. I have 4 pairs to spend. I need to pick a central atom. Carbon is always good. Hydrogen is always bad. That is the Lewis structure for water. The next thing I need to do is I need to ask myself, do I have at least one polar bond? I'm going to do that by looking at the difference in electronegativities. Hydrogen is 2.1, oxygen is 3.5. So I'm going to subtract 3.5 minus 2.1, and that gives me 1.4. Is that bond polar? Yes. I have to keep going. If that's no, the entire molecule is nonpolar. The next thing I need to do is I need to get the Vesper shape, because I have to, in the next step, look for the net dipole. How many areas of electron density are on the central atom? What is the electron pair geometry to get 4 things as far apart from each other as possible? Tetrahedron. Do you have any lone pairs on there to mess that up? Yep. Think away 2 of the tetrahedra. The shape that remains is bent. But Dr. V, you drew it like it's a straight line. Yep, I drew it like it's a straight line, but it's not. It's really bent. So, and I'll put those lone pairs right there. That would be the electron pair geometry. And when I erase those and do the molecular geometry, you can see it's not a straight line. All right, now I have to look for the net dipole. A net dipole means there's a region that's partially positive and a region that's partially negative. So I'm going to get rid of this because I don't like it up there anymore, because it ain't linear. It's bent. And I'm going to write it like this, just so I have a little bit more room. And it looks like this. Here's the oxygen and here's the hydrogen. Who's more electronegative, oxygen or hydrogen? It's the oxygen. So the 2 electrons right here in this bond, they're going to scoot. Do they scoot down to the hydrogen or up to the oxygen? They scoot to the more electronegative, so they go up here. These 2 electrons also go up here. So all my electron density is up here at the top. Now you have to ask yourself, does this molecule have a partially positive end and a partially negative end? And the answer is it does. It's a little hard to see, but if I could cut the molecule right here, everything above the pencil would be partially negative and everything below the pencil would be partially positive. Water is a polar molecule. These 2 electrons scooch that way. These 2 electrons scooch that way. And if I draw a line right there, all of this up here is kind of negative, and everything down here is partially positive. Water has polar bonds, and it is a polar molecule. You know, when you look at a glass of water, there's a surface tension. There's kind of like a film on top. Little bugs can walk on it. If you're really careful, you can lay a needle on it. That surface tension exists because water molecules are attracted to each other and they make a surface. It's the same reason why you get the little droplet that'll bead up on a freshly waxed car. The water is sticking to itself. That's all I have for you in this video. Thanks for watching, and I'll see you next time.